Swayam Prabha. Digital India. Educated India.
Welcome you all to lecture number 3 in the week 1 series. Topic of today's lecture is critical path method. So, in the previous 2 lectures I have primarily covered on the general aspects of project management, construction management and so on, and we have also discussed on what are the basic inputs required for scheduling and all the pros and cons with all the basic inputs, different methods available, we have seen all those. So, today's lecture we will be covering on the first logic driven scheduling method, which is called very famously called as critical path method or CPM. So, in this class we are going to see the terminology used in CPM and the 2 forms of CPM representation. One is activity on arrow diagram and the other one is activity on node diagram. So, both the methods we are going to see in today's class along with the scheduled representation and the network analysis. Okay, so CPM network representation generally has 2 terminology. One is called nodes, as you can see here. The nodes are generally in circle or in rectangles, and the other one is called arrows. Okay, so in the 2 types, the way you represent the activities along the nodes or arrows, we have the 2 methods. So if you see here the types of network diagram, there are 2 broad categories. One is called activity on arrow diagram, very famously called AOA, and the other one is activity on node diagram, and which is the AON method. Okay, the other names for AOA are IJ method, arrow diagramming method, and in your AON method we also call precedence diagramming method, but PDM is very generally referred for an advanced version of an AON. So, this is all on the background. Now, if you see the network representation, as I told you, where you represent the activities, therein only you have the 2 methods. So, in the first method, activity on arrow diagram, the activities are represented along the arrows as how the name also implies. Okay. So, if you see here, I am representing the events along the nodes and I am representing the activities along the arrows. Okay. So, activity A is represented here and I is the tail event and J is the head event. So, primarily any activity, I do not represent an activity, I primarily use the events to talk about the activity, and that is the real reason why we also call the AOA method as an IJ method. Okay. In the AON, as the name implies, activities are on the nodes. So, these are the nodes and activity representations are generally done on the nodes. So, here if you see, so this is the nodes and activities are represented here, and the arrow marks generally show the relationships between the 2 activities. Okay. So, that is how we have the 2 methods and these are the 2 representations for the same. Now, little more on CPM network schedule. So, let us look at little on the history. CPM network is a very old method, almost like 1950s or so it started and still going on. The first method which came in existence was a AOA method because of little problems with the dummies and etc. So, AON came into existence and people are very comfortable in using both the methods as the choice. Now, what are the assumptions in drawing the CPM networks? There are few assumptions. The arrows, whether it is AOA or AON, are generally drawn from left to right, and the orientation either horizontal or vertical, there is no backward links or something, and no curved lines are also available. And there are few formats for network representation. Okay. For example, arc format, which is not that predominantly used in practice. The other one is called sloping format. Sloping format generally has horizontal lines and also sloping lines, which we call it as an angular lines for representing the activities. So, it is represented like this. In star format, the same thing what we do is we represent in terms of horizontal and vertical lines only, there are no sloping lines, and as such there are 2 ways of presenting your diagrams. The length of the arrow generally has no significance on duration apart from methods like time scale diagram, bar charts and so on, but they are not called CPM network schedules. Okay. Generally any network schedule, the length of the arrow is insignificant of the duration. Now, activity on arrow diagram. So, we will see little more on that. So, the guidelines in drawing, so primarily you have head events and tail events. As I told, I is primarily the tail event and J is the head event. Numbering is generally done from left to right, okay, which implies it just starts from I and proceeds to Jth event and so on. And the length of the arrow, as I have told already, it has no significance on duration, even though you are representing the duration along the arrows. Okay. Then there is something called dummy activity, and as I said, it is a drawback in AOA, and for which only you had an AON diagram into existence. So, what is this dummy activity? Dummy activity is generally introduced in a CPM network either to show dependency relationships or to avoid duplicate numbering of activities. Okay. For any activity, I should have an unique I and a j, and this ij cannot be shared for an other activity. So, for that reason, and the other reason is just to show the logical dependency between the relationships, there may be a requirement of usage on dummies. These are the two reasons. In the examples which I am covering, I will show both the examples in how to use for where are the dummies coming in and what is the purpose of the same. Dummies are often shown by dotted lines. It is easy to identify. It consumes no time or resources. There is something called Fulkerson's rule. So, that talks about the forward numbering. So, I always has a number which is less than j, and there is also something called skip numbering adapted for large complex projects. Every project, whether it is a medium or large project, generally has changes are unavoidable. And if there is a change of scope of the work and few activities are added up, what happens is you may have to redo the numbering if you are planning in consecutive 1, 2, 3, 4, 5, 6 and so on. So, general advice is to leave some numbers or gaps in the middle and start like 10, 20, 30 or 10, 15, 30, 50 and so on, so that you can add activities with the change in scope of the project. That is the main reason on skip numbering. So, these are the general issues with AOA diagram. Now, let us take an example in order to really understand how to represent a AOA diagram and the analysis later on. So, first example primarily is a sewer house connection for collecting sewer from households and how it links to the public or street sewer. Okay. So, if you see here, this is a schematic diagram. I have a main pumping station, that is a sewer treatment plant. STP stands for sewer treatment plant and MPS is for the main pumping station. I have interceptors as shown here, and there are lifting stations also. There are pumps for pumping up the sewer collected also, and there are branches from the house, it just moves on and so on, and inspection pits, from the pits connections are all happening. Okay. Now, so little more on the layout. So, there are pressure flows, there are gravity flows in the area as well. So, you will have location of manholes like this. Lifting stations are all here located at station 1, station 2, station 3, and there are manholes also based on the slope and gradients and the pressure on the flow of the sewer. You may have to do either gravity flow or there can be pressure flow, and accordingly there are lines marked here on green and red, and there are several existing lifting stations also. New stations are also planned for connected with the existing stations in order to do the pumping action and collecting of the sewers to a line. Now, the scope of the present project is only on DWC pipes, double wall corrugated pipes, just for one manhole I have and the pipeline which I have as a connection. So, what are the activities, how is the duration calculated and how is the construction really done? Okay. So, let us talk only about the underground pipeline including the manholes. So, how do you plan for the whole section of the work? So, scope of the work is planned as 240 meter section. So, covering the entire flows, I have 240 meter of a stretch I am planning to take. So, how much time it generally takes for finishing up the entire tasks? Working hours per day is default is 8 hours per day, which is also taken. Manholes, general norms in this particular project was to be provided at 30 meters interval. So, approximately there is 8 starting with the connection or the starting points, you may have to do 9 manholes in the whole sections. Okay. So, now the activities for this particular construction, there were 6 activities we have taken. It was not completely exclusive, but we just took out only the major activities for the whole project. So, excavation, dressing and ramming, brickwork for the manholes, pipe laying and joints, then backfilling and compaction, and the surface PCC. These were the 6 activities that were taken. In order to have an easy way of writing IPAs and going ahead with the analysis, we also introduced an activity ID. So, A, B, C, D, E, F, IPA I have assigned based on the activity IDs of these activities only. If you see here, all activities are done in sequence except the activities B and C, which share the same IPA. So, they can be done in parallel. Okay. So, now what is the crew productivity? So, this is not rate per crew, this is a crew productivity. The productivity of the following crew that was planned for the project was, for example, excavation 30 meters per hour, and the crew size available was 1 crew size, and the crews available were 1 crew, which implies one group of only 1 worker was available for the entire excavation activity. So, duration taken is a simple formula which you always know. What is the quantity of work to be done, which is 240 meters divided by the productivity constant, which is 30. So, this will be like 8 hours is the duration for excavation. Now, for the second activity, dressing and ramming, so 20 meters per hour, and there were 2 groups, 2 workers were available in 1 group, and 1 group was only available at that time. So, 1 group of 2 workers, so it is primarily 240 by 20, which is actually equal to 12 hours is the duration calculation. So, similarly, all the durations for all the activities were calculated in that way. This is only to show how to represent, how to define the scope of the work, how to list out the activities, and how to get the duration. In this case, the resources were primarily driving out the duration, and the duration was not fixed as a constant, and then the resources were assigned. In this case, the duration came out naturally as a result of the crew size which were available. Okay. Now, this project is represented here. So, I have the list. So, from the previous table I have taken up, I need only these information. So, I am just showing up only the IPAs and the duration for all these activities. Okay. As I told, the activity B and C are in parallel. So, I have not shown that activity, but I have shown all the other sequential activities in the network. Okay. And the duration and the activities are represented along the arrow marks. Generally, activity is represented above the arrow mark as shown here, and duration is generally written below the arrow mark as seen here, and numbering is also done. Now, in this particular case, so this is primarily I am going to introduce a dummy, because if I connect the 2 activities like this, what will happen is I am going to share the same IJ for both the activities. So, I wanted to avoid that. So, what I have to do is there are several options for showing the dummies. Okay. Primarily I have to introduce the dummy. So, one option is, so I can introduce a dummy here, and then I can connect the activity. This is one way. The second way is, so from 2 to 4 I can introduce the activity, and then I can connect the dummy. This is activity B, this is activity C, this is activity B, this is activity C. Other option is, so 2 options are already shown here. The next option is I am going to connect my activity B as such. So, this is my activity B, introduce a dummy here, and then connect the activity which is C, or else I am going to introduce my activity here and then connect my dummy. Okay. In this way, how many options? I can have 4 options of putting the dummies, and all 4 options are equally good. It is primarily based on the convenience with which you are going to choose the options. Okay. So, now what I am going to do is I am just going to choose one of them here. Okay. So, this is the primarily the option which I have chosen, and I have just represented the network, but there are other options also available, and this dummy is introduced primarily to avoid the unique numbering of activities between the activity B and activity C. So, that is all on the AOA diagram. Now, let us move on to the other form of CPM representation, which is a AON diagram. So, the same example I am going to take. So, the same example I have taken, duration, everything I have taken from the previous example which I was listing out right now. Okay. So, now how do I represent these example? As I have told earlier, activities are generally written above the inside the circle, but above, and the durations of those activities are written below, but inside the same circle. And generally we use circle representation for a CPM network, and we use a rectangle representation for a PDM network, but the choice is among the users, you can use anything. Okay. So, this is how the activities are represented. So, after A I have B and C in parallel, and after B and C I have to start my D. After D is completed, E will start, and after E is done, F starts and finishes. This is a whole network. As you can see here, this is really an easy network to draw compared to AOA because of the absence of dummy activities. Okay. So, that is where this is most preferred compared to the AOA method. Okay. Now, moving on to network analysis. So far we have seen network schedule. The terminology when you say network schedules is primarily representing your networks, okay, on to the with either in the AOA format or in the AON format. And when the minute you say analysis, primarily you are going to do forward pass, backward pass, and critically you are going to find the critical activities in the path. Okay. So, network analysis is computation of forward pass and backward pass and identifying the critical path. Now, why should we do this calculation, and who owns the float or the slack? Now, there are two terminologies which are coming in. One is called float, other one is called slack. Float is a word which we generally use in the AON format, and slack is a word which we generally use in a AOA format. When after few slides you will understand that. Primarily what is it? It tells you how much is a delay in time you can actually delay any activity without affecting the final project duration of the whole project. Okay. Now, you know that there is a buffer time existing for a few parts or for few activities and so on. Now, who has a responsibility or who owns that free parts in the luxury of starting an activity or a particular stretch late or delaying and slowly progressing and so on? Is it owner or contractor? It is primarily definitely not the owner and definitely not the contractor. It should be a project related float. Okay. So, that should be a good, if there should be a successful projects to happen, then the projects should own the float and neither the owner or not the contractor. Okay. Now, let us see the first method, which is the AOA method, and the forward pass, backward pass, and the slack calculation. So, forward pass, it is a computation method to find the early event time of events, that what is the EET, early event time, and backward pass, it is a computation method to find the late event time of events, so which is LE and T. And slack is nothing but the spare time in the entire stretch of sequence of events, and generally slack is given as LET minus EET. Okay. Now, how do we represent? For representation AOA, this has been discussed earlier. For analysis, how do we represent? This numbering is not generally used when we are doing analysis. So, the late event time or early event time is generally represented inside the events, and then slack actually comes on one side. Okay. So, now this can be also altered. So, LET and EET. So, inside the circle I can also have EET and LET, and I can also write my slacks. This is also possible, and both the methods are equally fine. Okay. So, so whatever you want you can choose here, but generally this is the way to represent the analysis. Now let us move on. I am just going to take a hypothetical example right now in order to show the analysis in detail. Okay. So, I am just having a few activities here represented alphabetically A, B, C, D, E, F, G, H, I, and the immediately preceding activities for these activities are given as like this. Okay. And I can also have a table which can also equally have an ISA as well. Okay. So, it is primarily again based on convenience, but the default relationship procedure is to show it on IPAs only, and then I have duration for all these activities given here. Okay. Now, what do I wanted to do? First step, the last example was very simple, so it was easy for you to just represent the activities. This example, it is a little big, okay, as and when you move on and take a real construction project, you may have 50 activities or even more. So, how do you start and represent the activities? This is especially good for beginners. There is something called sequence steps. Okay. So, first step is to identify the sequence step for the entire table, so that it is easy for you to represent the activities and then connect the activities, so that you have a neat diagram in a very few round. Okay. So, sequence steps, how do you do? So, those activities which does not have an IPA will come in the sequence step number 1. For example, A, C and D does not have an immediately preceding activity. So, they all will form the first activity to start with. Okay. All those activities which had SS1, okay, will all become as a predecessors, will have the sequence steps number 2. For example, A, C, D had SS1s. So, those activities where all it is coming as a predecessor. So, primarily activity B, activity E, activity F will form as a sequence steps number 2. Okay. Now, what all the activities which have sequence steps number 2 as an IPA will all become the sequence steps number 3. For example, so it should be E, F or B. So, primarily the activity G and H is under sequence step number 3, and G and H is IPA for I, and hence that becomes a sequence steps number 4. In this way, if you progress, it is easy for you to finish up the entire arrangement of the activities. Now, what do you do after arrangement? Okay. So, first is AOA diagram. Okay. So, the same table I have shown it on the top for you to really correlate and understand. So, primarily the first sequence step, second sequence step, third sequence step and fourth sequence steps are given here. Okay. So, I have arranged my activities accordingly. This is activity on arrow diagram. So, I am representing all the activities along the arrows. So, A, C, D is written here, B, E, F is the second sequence step, G, H is the third sequence step and I is coming in the fourth sequence step. Okay. Next is connect all these activities using a dummy relationship. Okay. So, seeing these relationship which I have along the IPAs. So, A has no IPA and B has A, C, D as an IPA. So, I am having A, C and D as IPA. Then C does not have any IPA, D does not have any IPA. For E activity, I have C and D as my IPA. For F, it is activity D is my IPA. Then for my activity G, F alone is my IPA. For activity H, I have B, E and F, and then I have for activity I, G and H are my predecessors. So, connect all these with the help of a dummies. That will be the second step which you have to do. Okay. So, the diagram is something like this. Now, once you have connected all the relationships, then see whether you can remove some of the dummies, so that your relationship is still maintained, but you are unnecessarily you are putting all the dummies can be really avoided. Okay. So, in this particular case, for activity E, C and D are the predecessors. For activity B, A, C and D are the predecessors. So, keeping only these two dummies in order to represent the logical flow. The first example I showed a dummy representation to primarily showcase the unique representation of activities. In this example, the dummies are used for showing the logical relationship between the activities. Okay. And so, the next step will be like, now check for these relationships. Again, these three dummies can be easily removed. So, I have removed all the dummies, and to maintain the relationship, Okay. To maintain the relationship, so B, E and F is primarily for H, and for F it's for G, and then I have I, which is H and G. So, when you are removing the dummies, see to that and correct all your IPAs whether it is right or wrong, and then confirm for the figure before you are removing it. Now, check for each and every activity. I think all my activities are checked for all the dummies. So, this looks like a final network. Okay. Once the final network is arrived at, then the numbering generally happens. Numbering here I have given in sequence only. So, 1, 2, 3, then 4, and then after 5, 6, because I should be always less than G, and then I have 7 and 8. So, I have done my numbering also. Okay. Okay. And now paths. I have so many paths in this entire network. Okay. For example, there are 7 paths in this network: A, B, H, I, C. So, this is primarily A, B, H, I. Okay. Then I have C, a dummy, B, H, I. Then I have C, E, H, I. Then I have D, B, H, I, D, E, H, I, D, F, H, I, and I have D, G, D, F, G, I also. So, these are the different paths I have in this particular network. Okay. Now, so path explanation also I am just showing it along with this case. Now, the main issue behind us now, which is a critical path for me, and what is the duration for all these paths. Okay. So, now let us start the analysis segment. So far I showed you the simple steps in order to arrive at representing a network. Now, we will start with the analysis. Okay, the same diagram which I have taken up earlier. As I told you, numbering will not be done when you are doing the analysis part. Okay, so I am just taking the example again, and as is shown earlier, the representation for analysis, I have divided the circle into 3 segments, one for EET, one for LET, and one for the slack. Forward pass is primarily to calculate the early event time of events. Okay. So, now how do we start? As usual, so you have to start the first event at 0. Okay. And again, this also I forgot to say earlier. So, these 3, and every time you should see to that there is a one starting event and one end event, as here, instead of having multiple starts and multiple ends, to avoid dangling of activities. Okay. So, now here I am starting with 0. Okay. So, D has a duration of 6. So, the event for this particular event, the early event time is 6 here, and for activity C, so 0 plus 3 is 3, this is 6 plus 0 is 0. So, maximum is 6. So, I am going to keep this as 6. Now, coming back to A, so this is 0 plus 6 is 6, this is 6 plus 0 is 6, again there is no minimum maximum, but generally you are supposed to take maximum. So, this becomes 6. Okay. Now, for this particular activity I have 6 plus 3, I have to do this because this is in the successor list. So, 6 plus 4 is 10. So, this early event time of this event is 10. Now, coming here I have 3 arrows connecting to this event. 6 plus 3 is 9, 6 plus 2 is 8. Okay. As a result of 6 plus 3, this is 9, 6 plus 2, this is 8. Okay. And this is 10, 10 plus 0 is 10 here. So, I have 3 event numberings here. Maximum only you should take when you are doing the forward pass. So, this becomes 10. Now, if you look at here, 10 plus 6 is 16, okay, 10 plus 3 is 13. So, maximum is 16. So, this becomes 16, and 16 plus 5 is 21. This is primarily the forward pass. Forward pass, what you do? Early start for the first event, generally we take 0, and for all other events is maximum of the preceding events plus the duration. Okay. So, that is what we have to take here. Okay. Next is backward pass. In the backward pass, you have to generally start from the last late event, and then we have to proceed backwards, and late events are generally the for the successor activities is primarily minus, you have to subtract the duration of the activity and go ahead. Okay. So, backward pass is generally done in this way, and your forward passes are generally done from left to right. Okay. Now, we are seeing the backward pass. So, this is 21, 21 minus 5 is 16 here. Now, there are 2 lines which are 2 preceding activities after this event. So, 16 minus 6 is 10 here, and this I have one more arrow. So, I cannot do this. So, 16 minus 6 is 10, and if you look at here I have 10 minus 0 is 10 and 16 minus 3 is 13, and when you are doing the backward pass we have to take the minimum of the two numbers. So, this will be 10 here, I have written 10 here. So, 10 minus 3 is 7 here, then 7 minus 0 is again 7, 7 minus 0 is again 6 here. So, this will be 6. Now, 6 minus 6 is 0 here, okay. 7 minus 3 is 4, 7 minus 6 is 1. So, I have 3 even times and the minimum I should take, which is 0. Okay. So, that is how the backward passes are done. So, forward pass is generally calculation of yearly even times taking into the activities which are all preceding, and you should take the maximum of the value and then go ahead until completion. When you are doing the backward pass, you have to start from the last event and then proceed till the first event, and every time you have to subtract from the activities and go backwards with the arrows. So, you have to start from the head event and then proceed to the tail event every time. Okay. That is primarily the backward pass. So, I have got LETs and EETs. Now, the next procedure is to find the slack. As I told you, the slack formula is LET minus EET. Okay. So, 0 minus 0 is 0 here, 7 minus 6 is 1, 7 minus 6 is 1, 6 minus 6 is 0, 10 minus 10 is 0, 10 minus 10 is 0. So, you have to show for all the events. Okay. Once you have done all these calculations, primarily the events which have 0 as a slack are all on the critical path. Okay. So, primarily what happens, this event is having a 0 slack, this event is having a 0 slack, this is having a 0 slack, this is also having a 0 slack, this and this. So, all these are having a 0 slacks. Okay. Now, if you see the path, okay, so how many paths I am able to build? I can build D, F, H, I, okay, and the other path is D, F, G, I. Okay. Blindly if you go only with the slack values and then go ahead in fixing up your critical path, I may land up in the assessment that there are 2 critical paths in the entire network. Okay. But is the logic really true? If you see here 10 plus 3 is 13, 10 plus 6 is 16, you really know that G is not on the critical path. Okay. Now, coming back to the drawbacks in AOA method, one of the drawback we have already discussed. What is it? The presence of so many dummies in the network only to do unique representation of activities or to represent the logical relationships. In this network I had 3 dummies, in the last example I had 1 dummy. So, dummies are an one biggest disadvantage in a AOA diagram. The other disadvantage is sometimes you may be misguided with the values on the slack calculations. Okay. What to do in these cases? You may have to again work out on all these activities and cross check for your values whether they are on the critical path or not, and then you have to go ahead with the calculations. This is another biggest disadvantage in a AOA network. Okay. That is where people started preferring a AON method. Now, let us show the AOA representation again. So, now the critical path, as I told you, G is not on the critical path. So, the critical path is D, F, H and I along with the dummy in the middle. Okay. And the duration for this particular project has taken 21 units of time. That is how the critical path calculations are done. Okay. Now, in the AOA method, whether you are using or the AON method, the procedure for computation on analysis is same. First you have to do forward pass, next backward pass and the float calculations. In AOA we have slack calculations. Okay. That you should keep in mind. So, now forward pass, it is a computation method to find the early start and early finish of activities. There the focus was events, we were finding out early event time and late event time of events in AOA diagram. Now, we are going to see early start, early finish of activities. This is forward pass. Backward pass, same way, it is a computation to find out the late start and late finish of activities. Okay. Short forms are ES, EF, LS and LF. In AON, as I have told you, we generally have terminology called floats to show the free time or the delay with which we can have a delay the start of the activities. Okay. So, primarily the 2 very famous floats we generally use to find critical paths are total float and the other one is free float. Total float is also called as a path float, and free float we also call it as an activity float. You will see when I am explaining with an example. Okay. Total float, it is a maximum amount of time an activity can be delayed from its early start without delaying the entire project. Okay. So, this actually talks about the one stretch of an activity or one particular path. How much is a buffer or delay an activity can do without delaying that particular path in order to finish the, without delaying the entire project duration. So, the formula for calculation is either late start minus early start or late finish minus early finish of the particular activity. Free float, as I told you, it is also called activity float. It is defined as a maximum amount of time an activity can be delayed without delaying the early start of the successor activities. Okay. So, the formula is minimum of early start I plus 1, which is the next activity, minus early finish of the current activity. That is the formula we generally use here. In the free float, what happens? It only tells you what is the buffer time or delay I can have on the activity without affecting the successor activity on the whole network. That is what is the free float meaning behind. Okay. Now, let us see the representation. So, representation for AON is activity on the node diagram. This is known to you already. Now, for analysis, how do you represent? So, primarily we have two lines close to the activities. Why these two lines are only to show that it is for the particular activity. If you have a very clumsy network, very big network, and you keep putting all the 4 values, then you will not know for which activity these values are represented for after the entire calculations are done. Okay. So, early start of the particular activity A, then early finish, this is late start, late finish, and early start, early finish similarly for B, and total float generally rectangular blocks on the top of the activity, and free float is given by a small triangle at the below the activity. Again, these two symbols are only to avoid confusions and to show this is for the total float and this is for the free float. When I am having an activity which is below and I am writing 2 values, okay, then with the symbol I will know that these are the total float of the other activity and this is free float of this particular activity. Only for that these representations are given. Now, with this we will go back to the same example, not the same, I would say this is an other hypothetical example. Okay. And so, sequence steps as earlier I have given. So, these are the 4 sequence steps and all these activities are listed as per the sequence step as per this figure. I am not explaining the sequence steps again because this is known to you. Okay. Now, relationships, next step is connect all the relationships for all these activities. Here I have moved the activity G down because I know it will be crossing if I am putting it on the other side. So, I have purposely put the activity G down. Okay. And this, since I have 3 activities in the starting, I wanted to avoid the dangling. So, I have introduced a project start, okay, that can be in the same shape as the activity like this and you can introduce as project start. Okay, and that has a duration as 0. So, only to avoid the dangling of the activities, and this is my entire final network. Okay. Now, first forward pass, as I told you earlier. So, primarily you have to put 2 lines close to each other and forward pass is primarily again from left to right, calculation of early start and early finish of the all the activities. Okay. Project start, so I am starting at 0 and the activity duration is also 0. So, 0, this is also 0. So, you generally have 0. Okay. So, this 0, 0 and 0 all 3 will have the same 0 values. Okay. 0 plus 6 is 6, okay. 0 plus 3 is 3, 0 plus 6 is 6. Now, if you see activity B, there are 2 relationships before this, activity A and C. This is 6, this is 3, maximum time only you should take in case of forward pass. So, this is 3 comma 6 and the maximum is 6 here. Now, for this activity again I have C and D as my predecessor and the early finish of C is 3, early finish of D is 6, maximum only I am going to take which is 6. So, I am keeping here as 6 and this will be the same number because there is no other relationships. Okay. Now, 6 plus 3 is 9 here, 6 plus 2 is 8 here, 6 plus 4 is 10 here. Now, coming to activity H, I have 3 predecessors, one is 9, one is 8 and one is 10 with the as a result of B, E and H, F predecessors. Okay. The maximum is what I am going to take for the forward pass. So, this is 10. So, after so primarily I have to finish B, E and F to start my H. There is a logic to that also. Okay. If I start at 9, then F is not going to complete. Okay. So, I have to finish for all the 3 activities. When will all the 3 activities get over? That will be on day 10 only. So, I can start H at the earliest starting time of H is day 10 because I want to complete B, E and F before that. Okay. Now, this becomes 10, 10 plus 6 is 16, this is same as 10, 10 plus 3 is 13. Here again I have 2 relationships 16 and 13, minimum is maximum is 16. So, my value is 16 here. Okay. 16 plus 5 becomes 21. So, this finishes my forward pass calculations. Now, coming back to the backward pass always progresses from right to left, from the last event to the first event. Okay. In the forward pass I finished my early finish at 21, the same value is generally taken for the backward pass late finish. Okay. The same thing happens in the AOA also, the EET of the last event will be the same as LET of the last event. Okay. So, this 21 is here, 21 minus 5 is 16. So, this becomes 16, this also becomes 16, 16 minus 3 is 13, 16 minus 6 is 10 here. Okay. Now, coming here, so this is 10, this is 10 and this is 10, and for this particular activity I have 2 values 10 and 13. Okay. As I told you earlier, I have to choose a minimum when we are working on the backward pass. What is the meaning behind this? So, this stops on this, I can start even on 13, but what will happen, the latest time with which I can finish should be 10. Okay. So, that is the reason why I have to finish the activity F latest on 10th day. So, all these are primarily 10 as a result of this relationship. Okay. 10 minus 3 is 7 here, 10 minus 2 is 8 here, 10 minus 4 is 6 here. Now, this becomes same 7. So, this relationship is here. Now, here I have 7 comma 8, 2 values are there, minimum is 7. So, I am going to take 7. Here I am having 8 comma 6, same way I have 2 values and the minimum is 6. So, I am going to take my 6. So, 6 minus 6 is 0, 7 minus 3 is 4, 7 minus 6 is 1. Okay. Now, here 1, 4 and 0, minimum value is 0. So, I am going to do this as 0. Okay. So, this finishes my backward pass. Now, if you see here, so once I have done forward pass, I have done my backward pass, I know the early start, early finish, late start, late finish of all the activities I have calculated. Okay. The next step logically is to find the critical path. To find the critical path, we should calculate the float. Okay. Generally, you can do free float, total float, both the floats you can calculate, but default calculation is by using total float only people find the critical path. Wherever the total float is 0 in an activity, those activities will come on the critical path. Okay. Now, I am having the same network. Okay. So, how to find the total floats is primarily the late start minus early start or late finish minus early finish is what I said. Okay. So, it is primarily the late start minus early start, 1 minus 0 or 7 minus 6. So, both are same here, total float I am getting as 1. For activity B, it is either 7 minus 6 or 10 minus 9, both you can use any one of them. So, it is 1. Here 4 minus 0 4, 0 minus 0 is 0, 8 minus 6 is 2, 6 minus 6 is 0, 10 minus 10 is 0, 13 minus 10 is 3, 16 minus 16 is 0. So, I have finished my total float calculations completely. If you look at this network right now, where are the total flows 0 values? So, I have at activity I have at activity H, I have at activity F and also at D. This logically will be 0 because 0 minus 0 is 0. Okay. Now, this is also one of the other way to check whether your calculations are right or wrong. Obviously, in any network there will be minimum one critical path in a network, which and path in the sense it should be connecting the whole project, and there will be at least one path which is on the critical path. Okay. If it is not coming, then obviously calculations you have done some mistakes somewhere in the calculations. Okay. Now, let us move on to representing the critical path. So, D, F, H, I is on the critical path. Now, let us go back to the earlier AOA diagram as well. Okay. You also had the same network which is D, F, H, I was on the critical path. Okay. So, generally people do not do both the methods for calculations, but I am just showcasing it to you that you will get the same results whatever method you choose. Okay. So, the next is free float. So, how do you calculate the free float? Free float for any activity is, so the maximum is primarily the maximum of the early start of successor activity minus the early finish of the activity. Okay. For this particular activity I have only one successor and the early start is 6 minus the early finish is 6. So, 6 minus 6 becomes 0 here. For this particular activity I have two successors and both the values happen to be the same. So, 6 minus 3 is 3 for me. Okay. For the same activity D I have two successors, 6 and 6 are the early starts of both the activities, and for the current activity I have 6 as my early finish. So, this becomes 0 is my free float. Okay. Now, for activity B again I have only one successor. So, this is 10, 10 minus 9 is 1. For activity E, so this is also done. For activity E I have again only one successor. So, this is 10 minus 8 is 2 here. So, this is my free float. For activity F I have two successors, the early start is primarily 10. So, this is 10 minus 10. So, this becomes 0. Okay. Now, when I look at activity H, so the early start of the successor activity is 16 minus the finish activity is 16. So, 16 minus 16 is 0. So, this becomes 0. Now, for activity G, early start of successor activity is 16, 16 minus 13 is 3. So, this becomes 3 for me. Okay. And if for this particular activity I, what you have to do is I have to assume that there is one more activity which is primarily a finish, and what is the early start and early finish if this activity exists. So, this will be 21 only, this is 21. So, if you have to take that into consideration, so 21 minus 21 becomes 0 here. So, this becomes 0. Okay. That is how the free floats are calculated. If you look at the forward pass, total float and free float, so whatever activity I have, so for example, are on the critical path, the same activities will be on the critical path only for the free float also. So, you will have 0 for activity D, you will have 0 for activity F, you will have 0 for activity H, you will have 0 for activity I. So, even with free float also you can still find the critical path. Okay. Now, what is the meaning of the free float, that I will explain here. Let us assume I am taking an activity B. This means I have a 3-day duration for activity B. This free float 1 means I can delay the activity B to 1 day and nothing will happen to the delay in the critical path. That is the meaning of the free float I have here. Okay. But if you take in the total float values, the value of this total float which is again 1, this means this value of 1 I can delay my activity B, and because of the delay in activity B to 1 day, it will not affect my A, B, H, I path to delay in the completion. That is why it is called as a path float, and in this case it is called as a activity float. Okay. So, that is all on about the total float and free float. So, if I wrap up on the AOA diagram and the AON diagram, AOA diagram came in existence first and then AON came in. Drawbacks in the AOA I have covered up then and there, primarily the dummies and also sometimes misguidance with the values on the slack values, because we are calculating it on events. Okay. And so, in AOA we have forward pass, backward pass, primarily with the early event time, late event time and the slack calculations. In AON diagram, primarily activities are on the nodes and we have early start, early finish in the forward pass, late start and late finish in the backward pass. And two types of float we have primarily seen, one is total float and the other one is free float, and these two floats are predominantly used in the analysis, in the AON analysis. Okay. So, that is all about the analysis and the scheduling method in the CPM network. Now, what are the other types of floats in the CPM network? The next one is interfering float. These are all not much used, but there are other types also existing. So, it is defined as the maximum amount of time an activity can be delayed without delaying the entire project, but causing the delay to succeeding activities. So, this interfering float is generally TF minus FF, which implies total float minus free float. Okay. Next is independent float. It is a maximum amount of time an activity can be delayed without delaying the early start of the successor activities all put together, and without being affected by the allowable delay of all the preceding activities. Okay. So, as the explanation goes, the formula also is same way: minimum of all my early starts of successor activities minus maximum of the late finish of all my preceding activities. Okay, there is a mistake here, this should be LF, capital F. Okay, of all my preceding activities LFs, and when I have all my successor activities early starts. So, minimum of early starts successors minus maximum of late finish predecessors minus duration of the current activity will give my independent float. Okay. Negative float, sometimes what happens in the contract completion date, there may be a definite date called finish on or something, there is a definite constraint given there, and sometimes the project expands or delays beyond that when you are putting all your constraints, your resources, schedules and so on. What happens, your project schedule may go on a date which is beyond even the schedule completion, as planned schedule completion date. Then what happens in that sense, you may have a negative float coming into the whole project. Okay. That is primarily called negative float. Then next type of floats is terminal float. So, terminal float is nothing but I have a whole project and there is really a different time for my plan completion and also for the contract completion. Okay. In the earlier case I said, if the contract completion or schedule pressure completion is little early, you start getting a negatives on the floats. Okay. Sometimes it may have, let us assume I am having a project which is planned to be completed in 30 days as per my TF calculations, early forward pass, backward pass I have done, I have all finished everything. Total project duration for the entire project is coming out as 30. If the contract completion time is said something as 25 months, then what will happen is this 5 months primarily you will get as a negatives float all along the whole activities. Okay. Suppose if the project completion, contract completion time is something around 40 months or something. So, what happens? I can easily finish my entire project in 30 months, and the 10 months is primarily a real float which I have on the whole project. This is primarily called the project free float. Okay. Terminal floats are also called the project free floats. The next one is internal float. Okay. Every activity we are calculating a duration, okay, based on the resources, productivity calculations, crew size available. I am primarily calculating a duration for each and every activity. Sometimes what happens is that particular, let us assume I am planning for an 8-day duration for an activity. Okay. All the 8 days you need not be working on the activity, there may be buffer here and there may be a free time you can still take out from the whole activity. Okay. Which is what is primarily called the internal floats. So, within an activity itself it is possible that there is some kind of a float coming out, that is primarily called as an internal float. The next one is contingency or buffer. So, contingency should not be confused with the floats. Okay. Contingency is purposely you are giving an allowance onto the project, and that is primarily called as a contingency. So, contingency or buffer is an allowance specifically added to your schedule or a network to take into account of unforeseen circumstances. So, it is an unusual event that may or may not occur. Okay. That is primarily you cover it up as a contingency and cannot be assumed for ideal conditions when they are preparing the schedule. PERT allows contingency because it does contain 3 types of values like optimistic, pessimistic and most likely. So, the network itself has an uncertainty in the duration calculations, and PERT is another network technique which I will cover later, that does allow contingency in some way. Okay. And most of the contingencies may have little or no impact on the project duration. So, that is all on the lecture for today. So, today's class we have seen critical path method, the 2 types in the critical path method. One is the AOA diagram, AON diagram, the representation of these 2 networks the analysis of these two in terms of forward pass, backward pass, slack calculations in AOA, float calculations in AON, and the other types of floats also we have seen. Okay. So, that is all for today's class, and we will continue on precedence diagramming method in the next class. Bye.